Hi, in this video we're going to be going over an IB applications and interpretation question on differentiation, and this is a paper 1 question from May 2024, time zone 1. Alright, so here we have a block of sugar, and we put that block of sugar in a cup of coffee and it gets smaller, and that's the whole essence of the question. So part A says, what's the length of one side of the block after 20 seconds? So it does say here that the coffee is shrinking at 0.2 millimeters per second. So let's go ahead and start. All right, so 0.2 millimeters per second is the rate at which it's shrinking, and that's for 20 seconds. So if we multiply that by 20, we're going to see how much that block shrunk. And so once we do that multiplication, we get 4 millimeters. Now that's not the size of the sugar cube or the dimension of the sugar cube after 20 seconds. That's how much it shrunk. It started at 10 millimeters. So we're going to have to take that 4 from the 10 in order to see the new size, which is 6 millimeters. And so that is the size or the length of each side of the cube after that 20 seconds. All right, so that is A1. Let's go ahead and jump to A2. The volume of the cube, or the sugar cube, after 20 seconds. So if each side is 6 millimeters, we know that volume is length times width times height, especially for a prism, a rectangular prism. And so our volume here is 216 millimeters cube. All right, so the differentiation did not start yet, but now going into part B, it tells you that our function volume in respect to time is 1000 minus, let's make this a little bit bigger, 60t plus 1.2 t squared minus 0. Let's need a little more room. Hold on 1 second. All right, minus 0.008 t to the third. All right, so now we have to make sure that we remember how to differentiate. So a few reminders in order to differentiate, just in case we don't know how to do this. All right, put this in a different color off to the side. If you're asked for the derivative, or you're asked to differentiate, or you're asked to find v prime of t or dv over dt, all of these are the same question. And that is the rate at which the volume is changing. All right, so anytime you have to differentiate a constant, so let's say 1,000, it could be 10, it could be 1,000, anything that does not have a variable, it will become 0 when you differentiate it. So that is something good to know. So any constant, when differentiated, becomes 0. Any number with an x, so let's say, for example, 5t or 7x, or anything that just has the number and the variable in the question, when you differentiate it, the variable goes away and it becomes just that number without the variable. So that is also good to know. And then finally, when differentiating anything else, so let's say you have a coefficient and an exponent. So let's say we have something like, and I'll just make something up, 9x to the 4th. Whenever you're differentiating that, it has 2 steps. You multiply the coefficient and the exponent to get the new exponent. So that would be 36 in this case. And then you subtract 1 from the exponent to get the new exponent, and that would be 3 in this case. So whenever you differentiate, these things happen. So let's go ahead and actually practice this with the actual question. So v prime of t, that means the derivative of the volume. So we already spoke about what happens when a constant is differentiated. It becomes 0, but we don't have to write that, so we'll just leave it as nothing. Then we have minus 60, and that t goes away, which we spoke about right here. And now for the last 2 terms, we follow this rule here. We multiply the exponent by the coefficient to get the new coefficient. So 1.2 times 2 to get 2.4. 4. Then you subtract 1 from the exponent to get the new exponent, and you get an exponent of 1, which we don't have to write because t to the 1 is just t. So I'll leave that there. All right, and finally, we multiply once again. We multiply the coefficient by the exponent to get the new coefficient. So we get 0.024 t, and then we subtract 1 from the exponent to get the new exponent. So 3 minus 1 gives us 2, and that is our derivative. All right, so we've found v prime of t, and that's part B. Let's go ahead and move on to part C. It asks us to find the rate of change of the volume of the block of sugar when t is 20. And so it's important to know and to remember that whenever you differentiate, that is the rate of change of whatever this thing is. So we have found the rate of change of volume everywhere at any time between 0 and 50 seconds. So all we have to do to figure out the rate of change when t is 20 specifically is to plug 20 into this expression here. So let's go ahead and do that. V prime of 20 is equal to negative 60 plus 2.4 times 20. So again, I'm just plugging 20 in for t, minus 0.024 20 squared. And once you plug that into your calculator, you should get negative 21.6 millimeter cube per second. Now we know that that number should be negative because the volume is in fact decreasing. So the rate of change is going to be a negative rate of change. So that looks good. All right. So finally, part D asks us to state one reason why the side length might not always decrease at the constant rate. And that in itself makes sense that it cannot decrease at a constant rate forever, because then it would shrink until, well, you can't shrink into oblivion and then keep shrinking. But they're looking for something more than that answer. So I would say for this question, after 20 seconds, the cup of coffee is not as hot as it was 20 seconds ago when this experiment started. And so it will behave differently. So I'm going to write less hot. So behaves differently after 50 seconds. All right, and that's it. Stay tuned for question 10 and the rest of this paper coming up soon.